after the completion of gaseous state, liquid state in states of matter. Now, the other important state of matter, that is solid state, is what we have to discuss. This is again a very important chapter as far as the IIT JEE mains and advanced is concerned. Definitely questions are regularly coming in both mains and advanced from this topic. In this topic, mainly what we discuss is what are the characteristic properties of solids, how the solids are different from liquids and gases, what are the types of solids, then especially in the types of solids, this types of solids is mainly amorphous and crystalline. This crystalline solids are again further classified into 4 different types, that is molecular crystals, covalent crystals, ionic crystals and interstitial crystals. These are the 4 different types. And then further what also we have to discuss is about the crystal lattice. The different terms what we are going to discuss in this topic are crystalline lattice, unit cell, types of unit cells, and then the packing fraction, density of the crystal lattice, then arrangement of atoms or molecules or particles in the crystal lattice, then close packing. In this close packing especially, that is CCP and HCP, cubical close packing, hexagonal close packing. These are the things that what we have to discuss. Then in the crystal defects and the types of voids, that is empty spaces in this octahedral and tetrahedral voids, then ionic crystals. In the ionic crystals again we have different types: sodium chloride, rock salt type, cesium chloride type, then zinc sulfide, fluorite, antifluorite, woodsite, all these different types, how the ions are arranged, how many voids are occupied in that, all this. Then finally crystal defects. Due to crystal defects, what are the properties of crystal is going to change and what are the effects of crystal defects. Then electrical and magnetic properties of crystalline solids. This is what the overall picture, the overall contents that what we should discuss in this chapter. So, to start with, first when it comes to the types of solids, it is amorphous solid and crystalline solid is a basic classification of solids. What is the characteristic similarities or differences among these amorphous and crystalline solids? Amorphous solids, in the amorphous solids, the regular arrangement of atoms or molecules is not observed, whereas in crystalline solids possess definite regular geometry and shape. The atoms or molecules are arranged in a regular geometry or shape, whereas in amorphous solids there is no such regular arrangement, or even if regular arrangement is existing, that is limited only to certain fraction of the arrangement. That means for every different section of the total arrangement, the geometry or shape is going to change. And also another very important thing is that between one set of atoms and another set of atoms, there is a huge gap. There is a huge gap that exists. There is a long empty space that exists. So the packing in the amorphous solids is considered to be like very loose, whereas in crystalline solids it is very tight, very systematic. So basically the point is that in crystalline solids, a regular systematic arrangement of atoms will be taking place, will be having, and in the case of amorphous solids, no regular and systematic arrangement. But in crystalline solids, regular and systematic arrangement will be taking place. Regular and systematic arrangement of constituent particles. Here constituent particles are either atoms or molecules or ions, whatever it is. Okay. Now, as a result, what happens? What are the characteristic difference in properties we observe for amorphous and crystalline solids? Because of the no regularity, no systematic trend is observed or exists in the arrangement of atoms or molecules in amorphous solids. Amorphous solids do not possess sharp melting or boiling points. There you will have a range of melting or range of boiling, range of melting points. That means a sharp melting point you will not have. Similar, but whereas crystalline solids, whether you take sodium chloride crystal, cesium chloride crystal, sugar crystal, any this kind of crystalline solids, if you take, they will have a definite melting point, very sharp. For example, ice. Ice is a crystalline solid, which all of us know it very well. Now, ice being a crystalline solid, as you know that it has a sharp melting point of 0 degree Celsius. That is the characteristic feature of crystalline solids, right, sharp melting points. But whereas if you take amorphous solids like amorphous boron, amorphous silica, right, even glass is a supercooled liquid, which is an amorphous solid we consider. It is not a crystalline solid. It will not melt at one particular temperature. Different parts of the glass will melt at different temperatures, right. So this crystalline solids possess sharp melting points, but whereas amorphous solids do not possess sharp melting point. And another very characteristic property is that in amorphous solids, amorphous solids are said to be isotropic, whereas crystalline solids are said to be anisotropic. What is isotropic and what is anisotropic? Isotropic means characteristic of, it is the characteristics of light that the light, the wavelength and frequency of all emitted line is uniform, means single wavelength or frequency of light is emitted, or single wavelength or frequency of light is only emitted when light is passed. For example, the basic difference, amorphous solids, group of atoms will be in a particular geometry, then this is another group of atoms, then another group of atoms, like this the different types of arrangements will be there, but this is for amorphous. For crystalline, the regular arrangement of atoms so in the amorphous solids the arrangement of atoms of one set of atoms will be different from another set. So, here we will observe different types of geometries, irregular geometries, but here the distance between any two consecutive atoms is always the same in a 3-dimensional pattern. So, here suppose if, so this is what is the basic difference is already we told in amorphous no regular and systematic arrangement, in crystalline there is a regular and a systematic arrangement. So, this is what is the meaning. Suppose if a light ray is incident on it, then as there exists a large gaps in between, large gaps exist in between, and here the gaps are also very systematic. So, as a result here no multiple reflection or refraction, but here multiple reflection or refraction takes place. So, as a result, suppose if you consider them as the planes, if a light ray is incident over here, then it undergoes reflection, then it also undergoes the different so like this it undergoes multiple orders of reflection or refraction. As a result, the intensity of the light that is emitted out, the frequency, the wavelength, all will be different from one to the other. But whereas here as that is absent, all the light rays that are emitted, are of same frequency or wavelength. For example, if you take a prism which is a crystalline solid, when you incident a white light, then the emitted light will have 7 different colors. So, the meaning is that this is what, as we know, this being a crystal, when a white light is incident, we know that the light emerging out will have 7 different colors with GR. So, the frequency or wavelength of each ray emitted is different from one another, but whereas here all the light that comes out, the emerging beam will have same wavelength or frequency. This is what is the basic difference. That is, so having the same frequency or wavelength of all the emitted rays is what is called isotropic, and when the wavelength or frequency of the emitted rays is different, that is what is called anisotropy. So, the basic differences of amorphous and crystalline solids is that amorphous solids no regular arrangement, crystalline solids there is a regular arrangement. As a result, in the amorphous solids there is a sharp melting, the amorphous solids will not possess any sharp melting point, but whereas crystalline solids will possess sharp melting points. Example, ice which has a sharp melting point of 0 degree Celsius, and amorphous solids are isotropic, crystalline solids are anisotropic, means the light characteristic properties of light that is being emitted is uniform throughout the substance. In the case of amorphous solids, it is different, that is wavelength and frequency of the emitted light is different at different angles in the case of crystalline solid, right. Now, the next is what we have to look at is, in our syllabus mainly we concentrate on these crystalline solids and their characteristic properties. Of course, examples of amorphous solids is that the glass is one best example of the amorphous solid, and in fact amorphous solids are considered to be supercooled liquids, because the characteristic features, characteristic properties of amorphous solids are more close to the liquid rather than that of solid. So, their amorphous solids are considered to be the what you call supercooled liquids, whereas of course, the crystalline solids are the pure solids, right. Now, this amorphous solid, so the supercooled liquid, the best example is the glass which is a supercooled liquid, and also we have amorphous silica, amorphous boron, amorphous carbon, right, coal, coke, these are all amorphous solids, whereas crystalline, even the same element can have both crystalline and amorphous allotropic forms. For example, carbon has amorphous forms of coal, coke and all, whereas the crystalline forms of carbon are graphite and diamond. Ice is a crystalline substance, and we have also silica, SiO2 also has certain amorphous forms as well as crystalline forms, the different allotropic forms, and all the valuable crystals, gems, all these things are crystals. So, these are the examples of crystalline and amorphous solids. We give emphasis, our emphasis is mainly on crystalline solids as per our syllabus, right. So, now what we have to look at into is classification of crystalline solids, that is what we are going to see now.